In the early 2000s, Dubai embarked on an ambitious engineering endeavor. This project aimed to create new land through extensive reclamation efforts. The strategy involved building into the ocean rather than expanding inland. This approach was driven by the city's limited terrestrial space for development. The initiative sought to redefine Dubai's coastline and urban landscape. It represented a significant investment in innovative coastal engineering. This project envisions the creation of advanced marine communities. These are not simple sandbanks or basic docking facilities. Instead, the concept involves developing entire luxury communities. These sophisticated settlements are designed to emerge directly from the sea. The initiative represents a significant leap in maritime architectural innovation. It redefines coastal living by integrating high-end residential and commercial spaces with the ocean. The Palm Islands project was a monumental undertaking in modern engineering and urban development. Its construction involved redefining existing coastlines through extensive land reclamation. This ambitious project pushed the boundaries of engineering capabilities and innovation. It significantly transformed perceptions of what was possible in large-scale construction. The islands reshaped the global real estate market, setting new standards for luxury developments. The project's impact extended to urban planning and environmental considerations worldwide. By the 1990s, Dubai embarked on a period of rapid economic transformation. This significant growth was initially propelled by its abundant oil resources. Oil revenues provided the foundational capital for extensive development projects. The emirate strategically leveraged these resources to diversify its economy. This era marked a pivotal shift towards modern infrastructure and global integration. Dubai began establishing itself as a major regional and international economic hub. Dubai's leadership recognized the finite nature of its oil reserves. This understanding prompted a strategic shift in economic focus. The strategy involved significant investment in tourism and global finance. Emphasis was also placed on luxury development to attract international interest. Dubai's economic growth faced a significant challenge. A new economic direction required extensive beachfront properties. However, Dubai's natural coastline was inherently restricted. This natural limitation directly impacted the availability of prime beachfront land. The scarcity of such land posed a constraint on development plans. This restriction necessitated innovative solutions for expansion. Beachfront property is globally recognized as highly valuable real estate. Its desirability is driven by unique location, views, and access to water. The inherent scarcity of beachfront land significantly inflates its market value. For regions like Dubai, this scarcity poses a critical constraint on urban development and expansion. Limited beachfront availability impacts strategic growth and real estate market dynamics. Dubai faced the challenge of limited beachfront property. A proactive solution was conceived to address this constraint. The strategy involved the artificial creation of new beachfront land. This initiative aimed to effectively expand Dubai's total land mass. Dubai's urban development strategy diverged from conventional vertical or inland growth patterns. Instead, the city opted for an innovative approach of outward expansion. This involved constructing directly into the waters of the Persian Gulf. This method created new land masses for development, such as artificial islands. This unique strategy has significantly reshaped Dubai's coastline and urban landscape. Strategic decisions often extend beyond immediate practical considerations, encompassing broader objectives. Such decisions can carry significant symbolic weight, shaping public perception and global standing. An unprecedented project can serve as a catalyst for achieving these strategic goals. This approach aims to elevate a location or entity to iconic status on a global scale. The project's execution is designed to position the entity as a leading global icon. This strategy transforms a practical choice into a powerful statement of global ambition and influence. Palm Jumeirah is a globally recognized artificial archipelago in Dubai, United Arab Emirates. It is one of the most ambitious and renowned land reclamation projects worldwide. The island's unique design is instantly recognizable from an aerial perspective. Its distinctive shape mimics that of a palm tree, complete with a trunk and fronds. This iconic structure houses luxury residences, hotels, and various leisure facilities. The Palm Jumeirah is an artificial archipelago in Dubai, designed in the shape of a palm tree. Its distinctive layout features a long central trunk, forming the primary access route. Branching outwards from this central trunk are 16 distinct palm fronds. These fronds are meticulously engineered land masses, providing extensive waterfront properties. A crescent-shaped breakwater encircles the entire development, protecting it from sea currents. This iconic design maximizes coastline and creates a unique residential and leisure destination. A crescent-shaped breakwater is an engineering structure designed to protect coastal areas. Its curved form is strategically positioned to encircle and shield an entire island structure. This design effectively dissipates wave energy, reducing erosion and safeguarding the island. The breakwater provides crucial protection against strong currents and adverse marine conditions. The palm tree design is a deliberate architectural choice for this development. This specific design was selected to optimize the available beachfront property. Its primary function is to maximize the length of the developable coastline. This strategic layout enhances the value and utility of the waterfront area. The design directly supports the goal of extensive beachfront development. Artificial islands are designed to expand available land, particularly in coastal regions. The palm design refers to a specific architectural and urban planning approach. This design involves creating multiple fronds or extensions from a central point. Each frond effectively generates extensive new waterfront land. This newly created land is highly desirable for the development of luxury homes. Conceptualizing a complex shape represents a significant design achievement. However, translating this design into a physical structure in open water introduces unique challenges. The construction process in such environments is vastly different and inherently complex. This requires advanced engineering solutions to overcome the difficulties of marine construction. Deep sea construction presents unique engineering challenges compared to land-based projects. Traditional methods for building foundations, like those for bridges or skyscrapers, are not directly applicable. Pouring concrete directly into the open deep sea is particularly difficult. Factors such as immense water pressure, currents, and material dispersion complicate the process. This necessitates specialized techniques and materials for stable underwater foundation construction. Land reclamation is an engineering process used to create new land from water bodies. It involves extracting materials, typically sand, from the seabed or other sources. These extracted materials are then transported to the designated reclamation area. The materials are strategically deposited to raise the elevation of the seabed. This process forms new land that can be used for various developmental purposes. Engineers carefully plan and execute these operations to ensure stability and environmental consideration. The Palm Jumeirah project required extensive dredging operations in the Gulf. Over 100 million cubic meters of sand were meticulously extracted from the seabed. This massive undertaking involved specialized marine engineering and equipment. The extracted sand was crucial for the construction and reclamation of the artificial islands. The rainbowing technique is a specialized method for precise sand placement. Unlike simple dumping, this technique involves spraying sand into position. It ensures accurate and controlled distribution of granular materials. This method is often used in construction and land reclamation projects. The controlled spraying minimizes environmental impact and improves efficiency. Rainbowing is a specialized dredging technique used for sand placement. Dredging ships pump sand through long pipes, creating an arcing trajectory. The sand is propelled through the air, resembling a rainbow. It then settles precisely into its designated position, often for land reclamation. Island formation often begins with geological activity, such as volcanic eruptions or tectonic plate movements. Over time, molten rock or sediment accumulates on the ocean floor, forming a base. Through a process of layer-by-layer deposition, material builds up from the seabed. This continuous accumulation gradually elevates the structure above the sea surface. The distinctive palm shape, or other unique landforms, emerges as the island grows. Erosion and further deposition continue to shape the island's features over geological timescales. Advanced GPS technology is utilized for highly accurate positioning in various applications. It ensures precise placement of materials, such as sand, in construction or landscaping projects. This technology maintains critical tolerances, often within mere centimeters. Such precision is essential for structural integrity and design specifications. The intricate design of the island demands extreme precision in its construction. Even minor deviations in material placement can compromise the overall integrity. Errors, particularly in sand placement, pose a significant risk to the design. Such inaccuracies could lead to substantial distortion of the intended form. Maintaining design integrity requires meticulous attention to every detail during construction. Coastal environments are constantly shaped by dynamic forces, particularly the relentless action of ocean waves. Sand, when freshly deposited, lacks inherent structural integrity to resist these powerful forces. The individual grains of sand are easily dislodged and transported by wave energy. Without additional binding elements or compaction, sand structures are highly susceptible to erosion. This vulnerability highlights the constant challenge coastal formations face against natural wave dynamics. A crescent-shaped breakwater is a critical coastal engineering structure. It is designed to form a protective barrier against strong waves and currents. This shape helps dissipate wave energy, safeguarding harbors and shorelines. The construction of such a breakwater is indispensable for coastal protection. The Palm Jumeirah features a distinctive crescent-shaped breakwater. This critical structure was built to protect the artificial island from ocean currents and waves. Its construction involved the precise placement of millions of tons of rock materials. These rocks were carefully selected for their durability and structural integrity. The rock placement process required extensive planning and specialized engineering technique. The completed breakwater forms a robust barrier, safeguarding the Palm Jumeirah. Coastal environments are constantly exposed to the dynamic forces of ocean waves. These incoming waves carry significant energy, which can lead to coastal erosion. Strategic placement of structures, such as rock formations, is crucial for protection. Each rock is positioned to effectively absorb the kinetic energy of the incoming waves. This absorption process dissipates wave energy, reducing its erosive impact. Consequently, inner island structures and coastlines are shielded from degradation. A breakwater is a coastal structure designed to protect harbors and shorelines from wave action. This particular breakwater extends for over 11 kilometers, showcasing its immense scale. Its considerable length allows it to act as a formidable shield against marine forces. The structure effectively dissipates wave energy, safeguarding the areas behind it. A delicate engineering challenge involved ensuring proper water circulation within a crescent breakwater. Breakwaters are structures built to protect harbors and shorelines from waves. However, they can impede natural water flow, leading to stagnation and ecological issues. To counteract this, specific openings were designed within the crescent breakwater structure. These strategically placed openings facilitate the movement of water, preventing stagnation. This design ensures a healthy marine environment and maintains water quality within the protected area. In sheltered island areas, water circulation can be inadequate. Without sufficient water movement, these bodies of water can become stagnant. Stagnant water poses significant environmental risks to the ecosystem. This condition can lead to reduced oxygen levels and harmful bacterial growth. Environmental design often requires balancing conflicting needs and objectives. One critical challenge is providing robust protection against natural forces like waves. This protection is essential for infrastructure and coastal communities. Simultaneously, designs must maintain healthy environmental water flow. Adequate water flow is crucial for aquatic ecosystems and natural processes. Achieving this balance is a key aspect of sustainable environmental engineering. Freshly reclaimed sand refers to sand that has been recently deposited or placed. Immediately after its placement, this sand exhibits specific physical characteristics. A primary characteristic is its inherent instability. This instability means the sand particles are not yet firmly settled or interlocked. Consequently, freshly reclaimed sand typically lacks the necessary compaction. Insufficient compaction results in a loose structure, making it prone to movement or settlement. Construction on uncompacted sand presents significant engineering challenges and risks. Uncompacted sand lacks the necessary density and stability to support structural load. Initiating building construction on such a foundation can lead to severe consequences. A primary risk is the potential for buildings to sink or settle unevenly over time. This instability can result in critical structural failure, compromising safety and integrity. Vibrocompaction is an engineering technique used to stabilize ground conditions. It is primarily employed to mitigate risks associated with unstable or loose soil. The process involves using vibratory probes to densify granular soils. This densification increases the soil's bearing capacity and reduces settlement potential. Engineers utilize vibrocompaction to enhance the structural integrity of foundation. Vibrocompaction is a ground improvement technique used to densify granular soils. Heavy vibrating probes are systematically inserted deep into the soil layers. These probes generate powerful vibration, reducing the void spaces between soil particles. The process compacts the material, significantly increasing its density and strength. This method is particularly effective in sandy soils, improving their load-bearing capacity. Vibrocompaction mitigates settlement and enhances stability for construction projects. Ground reinforcement is a critical engineering process for enhancing soil stability. This method effectively strengthens the ground's load-bearing capacity. The strengthened ground becomes sufficiently stable to support subsequent infrastructure. It ensures a secure foundation for various construction projects and developments. Road construction requires meticulous preparation of the ground surface. A critical step in this process is vibrocompaction, which densifies the soil. This technique uses vibratory forces to reduce air voids and increase soil stability. Following compaction, the ground undergoes stabilization to enhance its structural integrity. Only after these processes are complete can the actual construction of roads begin. Ground stabilization is a critical preparatory phase in construction, particularly for luxury properties. This process enhances the soil's load-bearing capacity and prevents future settlement or structural issues. Various engineering techniques are employed to achieve optimal ground stability. Once the ground is adequately stabilized, it provides a secure foundation for development. This allows for the safe and reliable construction of high-value luxury villas. Such foundational integrity ensures the longevity and safety of residential properties. Major hotel developments require robust and stable foundations for structural integrity. Such large-scale construction projects often necessitate extensive ground preparation. This includes the process of compacting land to increase its density and bearing capacity. Compacted land provides a solid and uniform base, crucial for supporting heavy structures. Once the land is adequately compacted, it becomes suitable for significant construction. Hotel developments can then proceed, ensuring long-term stability and safety. Essential utilities were meticulously installed across the island. This included the establishment of a reliable electricity supply system. A freshwater supply network was also implemented to serve the community. Additionally, a comprehensive sewage system was developed for waste management. Comprehensive telecommunications networks were integrated into the island's infrastructure. This integration established robust communication channels across the region. The networks provide essential services for residents and businesses. They support various forms of digital communication and data exchange. This infrastructure enhances connectivity and economic development on the island. The Palm Jumeirah, an artificial archipelago, required robust infrastructure for connectivity. A monorail system was chosen as a key transportation solution for the development. This monorail was constructed along the central trunk of Palm Jumeirah. Its primary purpose was to establish a vital connection for residents and visitors. The monorail links the island directly to mainland Dubai, enhancing accessibility. The Atlantis. The Palm Hotel is a globally recognized landmark. It is prominently situated on the crescent Breakwater. This strategic location contributes to its iconic status. The hotel has become a significant symbol of the project it belongs to. Its distinctive architecture and location make it instantly recognizable worldwide. Atlantis the Palm represents a major achievement in hospitality and development. Large-scale projects inherently attract significant environmental scrutiny due to their potential impact. These projects often involve extensive land use, resource consumption, and waste generation. Environmental experts raise concerns regarding habitat destruction and biodiversity loss. Potential impacts on air and water quality are also critical areas of expert concern. Long-term ecological consequences and climate change contributions are closely evaluated. Such scrutiny aims to mitigate adverse effects and promote sustainable development practices. Environmental concerns often highlight potential disruptions to marine ecosystems. These disruptions can negatively impact existing marine life and their natural habitats. Such concerns emphasize the delicate balance within underwater environments. Protecting these habitats is crucial for maintaining biodiversity and ecological health. Water quality monitoring is crucial for identifying environmental concerns. One significant issue is water stagnation, which impacts aquatic ecosystems. Stagnant water can lead to reduced oxygen levels and increased pollutant concentrations. Another major environmental consideration is increased coastal erosion. Coastal erosion reshapes shorelines, threatening habitats and infrastructure. These issues highlight the need for comprehensive environmental management strategies. Engineers addressed identified concerns regarding existing water management systems. Key adjustments were implemented to significantly improve the overall water flow efficiency. These modifications aim to optimize the distribution and movement of water within the system. Concurrently, comprehensive monitoring systems were established to track performance. This dual approach ensures both immediate improvement and continuous continuous oversight of water flow. The project encountered significant financial challenges. These difficulties were particularly pronounced during the global economic crisis of 2008. The crisis presented an environment of widespread economic instability. Navigating such conditions required robust financial management and strategic adaptation. The Palm Jumeirah project faced significant development hurdles during its construction. Despite these challenges, the ambitious project persisted towards completion. It ultimately achieved its status as a globally recognized, prestigious address. The completed islands stand as a testament to human ambition and vision. This engineering marvel showcases remarkable ingenuity in large-scale construction.